got here this morning and none of this is working. And I was like, cute. Not a big deal. Okay, so 20. 20, okay, 20 is a little bit more involved. So let's talk about it. Given the roots of a polynomial, how do you write the polynomial in factored form, standard form? So given roots, ugh, how do we write the polynomial in factored and standard form? Do we already have an idea about this? Do we already know the answer? What do you think? Did we talk about this together? We did? Okay. Did we already do an example? Okay, so, well, I guess it's the video, so I have to go ahead and, I'm going to go ahead and talk about it all, and then yeah, okay. So, the best way for me to talk about this is to go backwards and say, if I gave you a function, let's say f of x equals x squared minus 6x minus 16, and I asked you to solve for the roots of the polynomial, then I would hope that you would factor it and say, I'm looking for the factors of negative 16 that add up to negative 6, and that's going to be 2 and 8, 2 with a negative 8. Yeah? So then, what would the factors be, guys? Okay, negative 8 and positive 2. So if I were to expand this out, I would get back to that, right? So then can you tell me what the roots are? Negative 2 and positive 8. Good. So if I give you the function, you can find the roots if you can factor it. So then my question is, if I give you the roots, can you find the function? So how do we write the function in factored form given, which is this form right here, given the root? So we put, let's say, instead of write, I'm going to put the roots in factors. And then what do you always write? If I told you the root was negative 2, then why is the factor x plus 2? You switch the sign because you always need to subtract it, right? So you can say writing x minus the root. So put the roots into factors, writing x minus the root, and that would get me factored form. So then how do I go from factored form? So how do I go? I already went from here to there, so how do I go from here to there? Okay. Yeah, so I distribute, or or you can say expand. So to get to standard form, you expand or distribute the factored form. Okay? And then I gave you some problems, or some roots, and I said, okay, given the roots, x equals 2, the square root of 5, and what is that, 3 minus 2i? Write the function in factored form. So let's talk about this. How many roots does this polynomial have if it has those 3 roots? Does it just have 3? Okay, so you're saying 4 because of the square root. So if I have the positive square root of 5, I must have what? I must have the negative square root of 5. So we need to add that to our list, comma. Is that the only one, though, that has a conjugate pair? Yeah, this right here is also, remember, so for the conjugate pairs, we have irrational and we have complex. So imaginary. This, 3 plus 2i, must also be a root. So these were roots that are implied but not stated. If you have this as a root in your polynomial, then you must have that. If you have this, then you must have this. Otherwise, if you expand it out, you would no longer have a polynomial expression. Okay, so we need to put this in standard or in factored form. So wherever we write f of x equals. Now I will say this is going to be a longer expression. So if you want to turn your paper sideways and write it, if you have more space that way, it kind of depends on how big your handwriting is. Okay? If the root is 2, what's the factor? So x minus 2. Cool. X minus the root. If the square root of 5 is the root, what's the factor? Okay. I'm a really big fan of keeping the terms together, keeping like terms together. So I'm going to go ahead and do this one now. If the root is negative square root of 5, what's the factor? Good. X plus the square root of 5. So we've taken care of those three. Now we have two more roots to put in there. So x, and didn't we say it's always x minus the root? Because I need to be able to plug in the root, subtract, and get 0. So that's what makes the function equal to 0. So it's going to be x minus, now here's what we're going to do. Did we talk about this yesterday? Okay, good. So notice how I put a parentheses. What we're going to do is we're going to we're going to plug in 3 minus 2i inside the set of parentheses. And do you see how we still have x minus the root? But what does that become? If we distribute that minus, what does that become? X minus what? So x minus 3 plus 2i. Okay, so we'll put that one down below it. And then what about the other one for 3 plus 2i? Do I do the same thing? Is it still x minus? It is. It's still x minus. So x minus, and then I put in parentheses the root. X minus. And the reason why I'm doing this, guys, is because I'm going to show you why it works, and then we're never going to do it again, okay? Not this way. So I put x minus the root, and if I distribute the minus sign, what does that become? Good. X minus 3 minus 2i. So do you notice how both of those, it's 3 plus and minus 2i? So I've got x minus 3 plus 2i and x minus 3 minus 2i. In the future, if we're working a problem and I say, hey, the root is 2 minus the square root of 7, then you can just be like, well, I've got x minus 2 minus the square root of 7, and I've got x minus 2 plus the square root of 7. As long as you always say minus this part, and then 1's plus 1's minus, I'm cool. I don't need to see where you distributed it, okay? So quick question, what if it was negative 2? This one, what about this one? Good, both of them. So I always just look at that first term. If it's a 3, x minus 3, and that's what we do, and then 1's plus 1's minus. So you see how that's a little bit longer? Okay. Now if we expanded this out, guys, the square roots would disappear, and the imaginary terms would disappear. Everything left over would be rational, actually would be integer values, okay? That's how it works out, or that's why it works out. That's why you need both of them. Do you want me to show you right quick that they disappear, or do you want to just, are you good? You take my word for it? Okay. Alright, so we have to do one more. It says write an expression for a polynomial with roots 2/3 and negative 6. So if the roots are 2/3 and negative 6, then what's the function? How do I put it in factored form? What would we write? X minus 2/3 and x plus 6. But let's talk about this right here. That's a rational root, and as far as polynomials go, you always got to have integer coefficients and not fractions, not rational numbers. So what do I need to do with that 3? Yeah. So we would actually rewrite this as 3x minus 2 times x plus 6. Now that is the factored form, but the prompt says write this one in what? In standard form. So what do we need to do with this? Distribute. Good. So I'm going to distribute 3x times x. What do I get? Okay. Now guys, hopefully you've expanded enough binomials with each other to know that the middle two terms are going to simplify together, right? What's 3x times 6? 18x. What's negative 2 times x? Negative 2x. What's 18x minus 2x? Okay, so we're just going to put plus 16x. And then what's negative 2 times 6? Negative 12. I have no problem with you doing that, writing both terms out and then combining them, but just save yourself the time and space if you can. Okay? Alright, that's 20. Let's talk about 21. Alright. Did we do this one yesterday? Okay. I think I did most of the later ones with my 8th period because they asked more of the later questions. Okay, 21. So 21 says, give an example of adding or subtracting a rational expression involving polynomial numerators and denominators. Requirement, they cannot have a common denominator initially, though they may share a common factor. So adding, subtracting rational polynomial expressions. Luke, can you give me a linear function, like an mx plus b? Okay, 2x plus 5. Baylor, give me a number. X minus 7 plus, Kana, give me a linear function. Okay, just like an mx plus b. Yep. Okay. 7x plus 14. Remember that she picked those larger numbers, not me. Okay, and then I'm just going to do x plus 1 to make it a little bit smaller for that one, okay? Sound good? Okay, so before we work that problem, let's talk adding and subtracting fractions, which you should have already done in an earlier number if you got to it yet, okay? Remind me, how do I add 2 ninths and 3 ninths? Right. If I eat 2 ninths of a pizza and then I eat 3 ninths of a pizza, I don't know why a pizza is cut into 9 pieces, but it is, okay? Then how much of the pizza have I eaten? 5 ninths, okay? Not 5/18ths. That would shortchange me. I got to eat 5 ninths, okay? So be happy for me. Now, what if it was 2/3 plus 3 ninths? Ah, I just used 3 ninths. That's a terrible fraction to use. Good Lord, I'm fired. Okay. Why is that terrible? Because it is 1/3. I'm going to change it. What if I was what if 2/3 plus 2 ninths? Do they have a common denominator now? How can I make them have a common denominator? The first fraction by just 3? So 3 over 3. True? So what does this become? Plus 2 ninths. I've eaten almost the whole pizza. Not out of the question. Okay. Now, what if it was 2/3 of a pizza plus 1/5 of a pizza? Okay, good. They share no common factors, so they need each other. Yeah? So I'm going to multiply this one on top and bottom by 5, and this one on top and bottom by 3. And I will have eaten 10 plus 3, so that's 13/15ths of a pizza. Okay. Although my favorite pizza is Papa Murphy's, the vegetarian, and it's gone now, and I'm like really upset. Okay, that's on the video for some reason. All right, so this expression right here, do these denominators share any common factors? Okay, is x a factor of it, or is it just a term in the whole factor? It's just a term. The only way that x would be a factor of something is if it was like x squared minus 7x. I could factor an x out of that, true? Then x would be a factor of that expression. As it is, the only factor that goes into x minus 7 is 1. So these two share no common factors, which means, just like the 3 and the 5, they need what? Each other. So, okay. Shh, cancel, stop. Good Lord. That was my alarm to stop the video, but we're going to finish this problem, then we'll stop it. Great. Okay, so this one needs an x plus 1, and this one needs an x minus 7. Agreed? Oh, because you like 7. It's also the power of suggestion. I had already mentioned a 7, and so 7 was in your head. That happens a lot. We're very susceptible to the power of suggestion. If you ever notice yourself like sitting across from someone and they do like an arm movement or a hand movement, you're more likely to do it as well. I had a friend. I never do this. I never do this. But we were sitting in an office having a meeting, and he did that. He did that. So then I did that, and I was like, why am I doing that? Like I never do that. But anyway, okay. So pet peeve of mine is for people to keep these in separate fractions. What was the whole point of us to have a common denominator? to be able to combine them into 1. So we draw one fraction bar, and in the denominator we put the common denominator. Okay? So the whole point is that now I can add the numerator. So if I expand this out, then I've got what? 2x squared plus 2x, I'll go ahead and write them, plus what? I gotta distribute the 5 now, right? So plus 5x, and then plus 5. Sorry, you probably said it and then I heard it differently. Okay, and then what do I write? Plus, so that plus right there is the plus that we're writing, plus what? 7x squared minus 49x plus, no, distributing the 14. That's okay. So 14 times x, so 14x, and then 14 times 7. Do y'all know how to easily do 14 times 7? Think, what's 7 times 10? What's 7 times 4? Add them up. And there you go. Yeah. Okay. So now we got to combine like terms. So 9x squared, 10, so 24, so negative 25x. Just take it my word for it, and if it's wrong, I'll take the blame. Plus 103. And then if we want to expand the denominator, we can. X squared minus 6x minus 7. But that is adding and subtracting polynomials. Now I have one more question before I end the video, okay? How would this have changed this entire problem if this had been a minus sign? I would have had to distribute the minus sign. So everything here would have changed sign on the second half. True? Okay. I'm going to end this video and then I'll pick back up at 22 in just a second.